PRZ stands for possible rational zeros. That means it may be a zero, it may not be a zero. Remember yesterday we talked about if they give us a zero and we find the other zeros? So yesterday we talked about given a zero, we'd find the other zeros, right? So today we're going to talk about how to make a list of things that might be zeros. So if all I'm given is the equation, being able to find a zero that works and then pick up and do what we did yesterday. Okay, so it's still building on what we did yesterday. There's just a little added step. They're not giving me as much information now, okay? So the first thing I need to tell you is how to find a list of possibilities. So let me give you an equation, and I'll show you how to do it. Let's do x to the third. Actually, let's make this 2x to the third plus 6x squared minus 5x plus 2. Now, if they gave me a zero and asked me to find the other zeros, then I would know that I would do what? Somebody say divide, so that's the right answer. I would synthetic divide. You weren't even here yesterday. You got it. Good job. I would divide synthetically by that zero on the outside, then I would factor and set each piece to zero, right? But here, and actually, let's make this 12 on the end instead of 2. Because I'm not given that, I need some place to start, okay? So I'm going to list possibilities, okay? So the way we list the possibilities, and these are not actual zeros, these are just maybe they are, maybe they're not, there's something to start with. We take the factors of the constant what? Divided by factors of the leading coefficient. What does it mean? Okay. So my question to you would be, what is the constant and what is the leading coefficient? Which one's the constant? 12. Which one's the leading coefficient? 2. Just the number in front. Just the number in front.
Wait, so leading is the biggest?
The leading coefficient is the one that's hooked to the beginning of the equation when it's in standard form. But the biggest exponent, yes, I think. And the constant is the one without a variable. So tell me this. What are the factors of 12?
1, 6.
I'm going to do a plus or minus in front because it could be positive or negative. 1, 2,
6.
3, 4, 6, and 12. What are the factors of 2? 1 and 2. I'm going to do plus or minus again because it could be positive or negative. So the way we list these possibilities is that we take all of these numbers, divide them first by 1. So my PRZs are, well, if I divide all these by 1, it's just all those numbers, right? All right, so 1, 2, 3, 4, 6, and 12. So I took all these numbers on the end and I divided them first by 1. Do we see that? So I'm done with that one. Now I'm going to take all these numbers and I'm going to divide them by 2. 1 divided by 2 is a half, right? What's 2 divided by 2? That's already on the list. I don't have to rewrite it. 3 divided by 2? 3 over 2. Yep. All right, I'm still dividing by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. 12 divided by 2 is... So these are all the PRZs. I don't have to do any more. Okay? Did y'all understand what Aaron said, though? The bigger that number in front or the more factors it has, the more PRZs you're going to have. Okay? What? Say again. That's your answer. That's your list of PRZs. That's not the actual zeros. That's a list of possibilities.
How'd you get 3 over 2?
Because I took all of these numbers, after I divided them all by 1, I divided them all by 2. Because the factors of the first number are 1 and 2. Let me show you another. Let me show you another one that then we'll take all the way through. No, that one was just listing. X cubed plus 9x squared plus 23x plus 15. Yep. Now, I was done listing the PRZs. It depends on what the question asks you. That one, I just wanted you to list out the PRZs. So if I'm just listing the PRZs, then yes, that's all I have to do. I'm fixing to solve, so the directions for this one are going to be a little bit different. The directions, say again?
Yeah.
23, yeah. The directions for this one are going to be find all zeros. Okay? So in order to find all zeros, the first thing that I want to do is list the PRZs. Okay? So to do the PRZs, I have to know the factors of the constant, and I have to know the factors of the leading coefficient. So what are the factors of the constant? What is the leading coefficient? I don't see one there. 1. What are the factors of 1? 1. 1's the only thing that can go into 1 without a remainder. So to find the PRZs, I simply have to list these numbers. You take all those numbers, because what I'm doing is dividing by the factors of the beginning. Since the beginning is the only factor is 1, dividing them by 1 just gives you itself. Now, if that was a 2 in front, I would also have to go through and divide them all by 2. Does that make sense to you, how I'm finding that listing of numbers? Okay. My next step, and here's where the guess and check kind of comes in. And I want you to think about what we did yesterday before you answer this. I need to find a true zero. Of that list, I need to know which one is a true zero. How do I know? What happens with true zero? What equals 0? The remainder equals 0. So if I want to test to see if they're a 0, what can I do? I can synthetically divide using that. Plug it in on the outside there. So until you get to the one that gives you a 0 remainder. So this is why I told you whenever we do synthetic, you'll want to learn the shortcut, because there's going to get where we're testing points. And if you test them synthetically, it's a lot quicker than testing them with long division. Keep the sign. I'm going to put here remainder of 0 so that you remember that's what I'm looking for, right? I'm looking for one that has a remainder of 0. So there ain't nothing to it but to do it. Let's start testing them. We'll divide first by 1. Maybe you don't like 1. Maybe you start with 3 or 5. It doesn't really matter what you start with. When you get to the one that has a 0 remainder, you can stop. Okay, and then we're going to finish solving from there. So what goes inside here? 1, 9, 23, 15. We're going to divide. Drop it, multiply it, add it. Multiply it, add it, multiply it. Ooh. It won't. You'll find most of them are one at the beginning when you start with. They won't be too bad. All right, this does not work. Why does it not work? See that 48 there? That means nope. You thought. But you thought. No, I'm just kidding. Come on, pen. All right, let's try the next one. I'm going to try negative 1. Because understand, you know that's what the plus or minus means, right? It's not. It's not just 1, 3, 5, 15. It's 1, 3, 5, 15, and then. You can stop once you find it, though. Did you already find one, Aaron? It's 3? Okay. Let me go through and show you this one to show you that it doesn't work. It's -1. Look what happened. When I got to -1, that might also be a 0. There's not just one answer, okay? All right, so several of you are saying, wait, I got 3, but watch what happens. Let's finish the problem and watch what happens. All right, so can we all agree based on the -1 up here that -1 is a 0? So my directions were to find all zeros to start with. So if I now told you find all zeros given x equals -1 is a 0, then it looks like a problem we did yesterday, right? I gave you the function and I gave you a 0 and you found all the rest. So you divided by that 0, then you factored and you set each piece to 0, right? It's the same problem. The only difference now is they're not giving us the 0. We're guessing checking until we get the 0. Does that make sense to you? So we're plugging things in until we find the one that works. At the point that we find the one that works, I like these problems because these are cumulative. They're very cumulative. You have to what? Yep. So we're going to write as a multiplication problem. So look at this one. If -1 is on the outside, what is the factor? X plus 1. It changes. Good job. Remember when we divide by the factor, we change the sign on the outside. And what is left when we divide? What goes in here? X squared okay? How do you know what? Because remember, this is remainder, constant, x, and x squared when we divide. Yep. Yes. The one that works, that's the key. The one that works. That's not the end. We're not, guys. All right, so just like yesterday, we're going to factor completely. Okay, so looking at that quadratic that's in parentheses. This is 1. 1 times 15 is 15. What two things multiply to 15 but add to 8? 5 and 3. So I have x plus 1, x squared plus 3x plus 5x plus 15. This is old hat for you now, yes? Slash it. Guys, I see a lot of you doing things that are not math. I need your attention. This is probably going to weight the heaviest on your test because it is the most cumulative. It's probably going to be Tuesday, Monday or Tuesday. It'll be Tuesday. Yeah, this is the last thing on the test. All right, All right, here we go. I've got x plus 1. I'm still factoring completely. I'm still on step 4. Take out the x. Somebody said x plus 3. What about 5? Remember whenever I told y'all when I taught you factoring that would be the most fundamental thing we did here? Do you believe me now? All right, so I'm going to take out the x plus 3. And I'm left with the x plus 5. Now, rewinding back to the beginning of the problem, what were the directions? What did I ask you to do? Find all zeros. So to find the zeros, I set them to 0 and solve. That's right. So I get x plus 1 equals 0. X plus 3 equals 0, and x plus 5 equals 0. -1. Now look, some of you said that -3 worked in the beginning. There's why it worked. It was a 0. Had you kept going also, that -5 would have worked. So it just depends on where you start with as to what you're going to end up with. But I just really want you to see that it's the same thing we've been doing. The only difference is we're not given the 0 to start with. We're testing points to see which one is the 0. I'll give you a second to write it. I want to do one more with you. What time is it? Public class work. This is number 25 from your homework. Let's do one together. This is, and I want to do this one because it's a little bit different. It's a little bit tricky. This is number 25. I got 2x cubed minus 7x squared plus 9. My directions are to find. Good job. I was trying to trick you. You got it. I'm missing that 0x. Does everybody see that? First thing we notice is that we need a placeholder. Okay? So it might help you if you go ahead and do that as your first step. So we get 2x to the third minus 7x squared plus 0x plus 9. Okay? Let's list the PRZs first. So when I list PRZs, I need factors of the constant divided by factors of the leading coefficient. Right? So the only thing I've got 1 and 9. How about factors of the leading coefficient? 1 and 2. Yeah, this is number 25 from the number. Alright, so I want to take all the factors of 9 and divide them by 1. Then I'm going to take all the factors of 9 and divide them by what? 2. Alright? So, divided by 1 is pretty easy because they just remain the same. That's right. But now if I divide them by 2, I forgot the first one. 1 over 2, 3 over 2, 9 over 2. Oh dear, I hope this one's looking. I didn't look at the answer first. I just have a nice 0 in my house. So let's just start. Let's have, I tell you what if y'all try positive 1, negative 1, positive 3, negative 3, positive 9. I'll try negative 9, and we'll see who comes up to a 0 remainder. Try positive 1, David's row, negative 1, Cubby's row, positive 3, Eric's row, negative 3, Darius' row, positive 9. And I'll do negative 9. See who gets a 0 remainder. Don't forget your placeholder. Ooh, it's not going to be mine. Is it 3? Let's see. We're taking all these numbers, David, that we listed out, and we're dividing them in. Yeah. Good job. It's positive 3. Yep. So you see, it's not, it didn't take us, I mean, at positive 3 it was done most of the time. If I made it through the whole numbers, or if I was starting to get through them and I didn't find one, I would go back and check my placeholders. I would also go back and check to make sure my math is correct. But 1/2 is a common one too. Usually 1, 2, and 3, and then a half are pretty common. But let's go ahead and set this up as a multiplication problem. X, what? Minus 3 times 2x squared minus 1x minus 3. Does everybody see where that comes from? That's coming from here and from here. It changes whenever it turns into a factor, though. Yep. Yeah, because that's the 0. It's already set equal to 0 and solved there. So. All right. Say again. Yep. So now, what do I do? Factor it, right? Give me the two things that multiply to negative 6, but add to negative 1. Yeah, negative 3 and 2, right? It's going to add to negative 1. So I'm going to do 2x squared. I always do my negative first, but they're mixed signs. Right? How about those first two? What can I take out of those two? X? What's left? How about the second two? Ugh, freaking 1. So what's left, I just hold the place for the 1. What's the factor that comes out then? And woo! Again, this is what we've been building up to all week, right? We started out with one factor and factoring, and then we started out with 1 0, and we found zeros, and now we're just kind of pulling everything together. I really hope y'all are seeing that connection that it's building on what we've done. Now everything to 0. So this is the longest of the problems that we do just because it pulls everything together. You have to be able to factor. You have to be able to find PRZs. You have to be able to do all that in order to find all the zeros. So here, I add 3. Hey, look, we're going to miss you. All right, so I get x equals 3. X equals 3 over 2. X equals negative 1. How many solutions should I be getting? What tells me how many solutions I should get? That biggest x equals 3.